Welcome! Today we will talk about linear probabilistic modeling. This is a very simple yet useful modeling technique used in engineering and the sciences. A linear probabilistic model is used to quantify the linear relationship between an independent variable such as x and a dependent variable such as y. With this model, we can find expected values of y for certain values of x. Let's take a look into how the linear probabilistic model can be derived. Here we have a scatter plot of a data set. We can introduce a line of best fit, a regression line, through this data set and get an equation. Here is that exact same scatter plot with the equation of the regression line in its general form. Y equals beta naught plus beta sub 1 times x plus epsilon. In the equation, beta naught is a y-intercept of the line, beta sub 1 is the slope of the line, and epsilon is called the error term. As we can see from the scatter plot, the line did not go through all the data points perfectly. Instead, each data point can either be above or below the regression line. This variation results in the error term. However, we can recall that the equation of this regression line did not have an error term. The error term usually has a value of 0 because our data points are just as likely to fall above the regression line as they are to fall below. Now that we have talked about the meaning of the linear regression model, let's take a look at an example of how biologists use a model to predict the number of cells in an experiment. Often, biologists quantify the number of cells in their culture using a chemical reagent that cells react with to emit light. The intensity of the emitted light is correlated with the number of cells in the culture. The higher the emission, the higher the number of cells. Biologists would first need to create a calibration curve where they plot emission intensity to known number of cells on a scatter plot and perform regression analysis to get an equation. We can see that the equation is emission intensity equals the slope of line times cell population plus the y-intercept. With this regression line equation, the biologists can now run their culture samples, obtain the emission intensity, and then back calculate the number of cells. We hope that you learned something useful about linear probabilistic modeling. If you have any question, please feel free to leave a comment below.